Welcome to StudyChem E channel. In this tutorial video, we are going to solve a problem on heat transfer through a composite wall or a composite slab. We have a composite wall made up of 3 layers. The first inner layer is a fire brick, the middle layer is made of steel, and then the last layer, which is the outer layer, is a ceramic blanket insulation. We have been told that we have to calculate the rate of heat loss through the vertical wall of a boiler furnace of size 4 meters by 3 meters by 3 meters high. And then we are given the thermal conductivity of each of the material of the wall. The thermal conductivity of the fire brick is 0.4 watt per meter Kelvin. That of the steel is 54 watt per meter Kelvin. And that of the ceramic blanket insulation is 0.2 watt per meter Kelvin. The inside temperature of the furnace is 600 degrees Celsius, and then the outer temperature is 60 degrees Celsius. Thickness of the fire brick is 25 centimeters, that of the steel is 2 millimeters, and that of the ceramic blanket insulation is 8 centimeters. We are to calculate the rate of heat loss through the vertical wall. So let's get on with the solution. We need to indicate our resistances. The thermal resistance for heat conduction through the first layer is RTH1. The second one will be RTH2, and the last one will be RTH3. We need to draw our temperature profile. The heat transfer is occurring from the inner wall to the outer wall, and so we get the temperature profile as the decreasing slope, where temperature is decreasing from T1 to T4, from the inner wall to the outer wall. So our temperature profile slows down like that. The rate equation for the heat transfer through the composite wall is going to be the overall temperature difference divided by the overall resistance. We can calculate the overall temperature difference by the initial temperature difference, that is T1 minus T2 plus T2 minus T3 plus T3 minus T4. That gives us the overall temperature difference. So we can see that we can do some cancellations. Minus T2 cancels plus T2, and minus T3 cancels plus T3. In effect, the overall temperature difference is going to be T1 minus T4. That is the inner one minus the outer one. Putting in our values, the overall temperature difference is 540 degrees Celsius. The next thing to do is to calculate the overall thermal resistance, and that is going to be the sum of the individual thermal resistances. We know that thermal resistance is going to be thickness, or the distance of heat transfer, divided by thermal conductivity multiplied by area. That gives us the thermal resistance. We need to calculate our area. We know the height, we know the length and breadth, and area is going to be the length multiplied by the breadth. That gives us 12 meters squared. So we can move on to calculate the overall thermal resistance. The first thermal resistance is going to be for the fire brick, and that is 0.25 divided by 0.4 times 12, plus that of the steel, which is 0.08 divided by 0.2 times 12, plus that of the ceramic insulation, which is 0.002 over 54 times 12. So we have the overall thermal resistance to be 0.08542 Kelvin per watt. Now we have the overall temperature difference and the overall thermal resistance. We just divide the temperature difference by the resistance. That gives us the amount of heat transfer to be 6,321.70 joules. Whenever you have a problem like this, it will be very easier for you to analyze it by first drawing the temperature profile, stating your rate equation, and then finding your temperature differences and your thermal resistances separately. After finding all those things, you then put them together to obtain your answer. More tutorial videos on heat transfer, energy balance, strength of materials, and all the other important courses are coming up. And these tutorials are aimed at helping you to be able to solve most of your problems in the courses that you are doing. My name is Joe White, third year Chemical Engineering, KNUST. This is a part of the Franklin's Learning Initiative. Thank you for watching.